Hello dear students, welcome you all. So in this lecture, I am going to start a new lecture series. This lecture series is basically for the students of BSc first year, and the course in this lecture series that I am going to cover is mechanics. So in this lecture series, I will try to solve the previous year question papers of mechanics course of BSc first year, right? So here in today's lecture, I am starting with the question paper of 2019, right? You can see here on the screen the question paper for mechanics course, right? We know very well that in BSc first year we have two courses, DSC courses. One is mechanics and other is electricity, magnetism and EMT theory, right? So I'm starting with mechanics course, right? So you can see here, I'm starting with the section A, right? You can see here section A. We know very well that section A in this question paper is a compulsory section. For the students' knowledge, I want to tell them that the question paper contains A, B, C, D, E sections. Section A is mandatory, compulsory, and it is based on either short answer type questions or multiple choice questions. And the other sections, section B, C, D, E, they contain long answer type questions with optional questions, right? So the students have to attempt 5 questions in all, selecting one question from each section B, C, D, E, and the section A is compulsory. You can see here it is compulsory, but in section B you have to attempt either this question or this question, either question number 2 or question number 3. Similarly, the same situation is for section C, D, and E, right? I will take them all one by one, right? And your this examination will be of 50 marks, and the section A is of 14 marks, and the other 4 sections would be of 9 marks each. You can see here 549, 549. So 9 into 4 sections 36 plus 14, 50, right? So now I'm starting with the section A, compulsory section. You can see here the first question in the compulsory section, question number 1, A. What do you mean by a differential equation? The one thing that that students I want to tell you that this section is actually compulsory section, and the answer that you are going to give here, they should be very crisp and short answer type. Don't go for the long answers because the question is of just 2 marks, right? So you try to give your answers in a very precise, crisp manner, right? Which is directly related to the question. So here, the first part of this section is what do you mean by differential equation? So we know very well that differential equation is basically a mathematical equation that connect or relates some function with its derivative. This is the simple answer to this question, right? We have a mathematical equation which relates or connects with the function with its derivatives. Now the function that we are talking about, function plus its derivatives. Now functions plus derivative. Now what is a function? Function would be definitely a physical quantity like displacement, right? Velocity, acceleration, right? Current, it can be momentum, anything, any physical quantity, even charge, right? Any angular momentum, any physical quantity can be there which would be linked with its derivatives, right? And that equation will be a differential equation, right? Very famous example of the differential equation is the second law of thermodynamics, F is equal to ma. So if I write a in terms of derivatives, we know acceleration is the derivative of velocity, so I can write F is equal to m d square x upon dt square. We can write it in this way, or we can even write it F is equal to m dv upon dt. It is the derivative of velocity, it is the double derivative of displacement, right? So both these, now I can simplify these further equations. It will become F minus m d square x upon dt square is equal to 0, right? Now this is a differential equation. Similarly, the second one, F minus m dv upon dt, right? It is again a differential equation. So in this way you can have large number of differential equations. You can give examples, right, of the differential equations, right? You can also tell that what is the order and degree of a differential equation. Order means the highest order derivative present in the equation. For example, here the highest order derivative is 2. So this is the order of this differential equation. You have learned about it in your 12th and 11th class also. And degree of the differential equation is the power of the highest order, right? So here the order is 2, but the power of this derivative is 1. So this differential equation has degree 1 and order 2. So it is a second order first degree differential equation. So you can in this way give examples, and this is the answer to this question, right? Now I am coming to question number 2. The question number 2 is you are given spherical polar coordinates 8, 30, 50. 8, 30 and 50, right? 8, 30 and 50. Let me check it. Not 50, but it is 45. Sorry, wrong. It is 45. Angles are theta phi degree, right? We know very well these are what? These are spherical polar coordinates, SPC. I am writing them. You can see here the spherical polar coordinates of a point P are this. You are asked to calculate the Cartesian coordinates. Now the Cartesian coordinates, this is equation number question number 2, right? We know very well Cartesian coordinates are x, y and z, right? Whereas the spherical polar coordinates are r, theta and phi, right? So first of all you have to have the knowledge that what are the spherical polar coordinates r, theta, phi, and what are the Cartesian coordinates x, y, z. Then you might have to remember that what is the relation between these two. So the relation is x is equal to r sin theta cos phi, right? Y is equal to r sin theta sin phi, and z is equal to r cos theta. This is the relation between the Cartesian and spherical polar coordinates. So z is equal to r cos theta. I am calculating the z. R means 8, cos theta value is 30 degree, right? So cos 30 under root 3 by 2, right? So it becomes 8 multiplied by under root 3 by 2. So it will give me 4 under root 3. So the value of z Cartesian coordinate is 4 under root 3. Now I am coming to the value of x. Sorry, x is equal to r. R means a sine 30 degree and cos it is 45 degree, right? R sine theta cos phi. This is phi, right? So sine 30 is 1 by 2 and cos 45 1 by under root 2. So 4, it becomes 4 divided by under root 2. So when I multiply by under root 2, so it becomes 4 under root 2 divided by 2. So it is 2 under root 2. This is the value of x. Similarly, I can calculate the value of y, right? So y will be what? R sine theta, r sine 30 degree into sine phi sine 45 degree. So 8 into sine 30 1 by 2 into sine 45 1 by under root 2, same thing. So what the answer? 2 under root 2. So this is x, y and z. So now I can write the corresponding Cartesian coordinates x, y, z. They are x is 2 under root 2, y is 2 under root 2 and z is 4 under root 3. So this is the answer, right, to this question. Question number 2. The spherical polar coordinates of a point are given and in this way. Now students, in some questions examiner can give you the reverse situation where you will be given the value of x, y and z, right? And you would be asked to find out the value of r, theta and phi. So in this case, how you can calculate the r? R will be equal to x square plus y square plus z square under the root. This is the equation that connect r with x, y, z. So if x, y, z are given, then you can calculate the value of r, right? Similarly, we know z is equal to r cos theta. So if you have calculated the r, then cos theta is equal to z upon r. Now you have calculated the r, you have given the value of z, so you can calculate the value of theta, right? So once you find the value of theta, then you can find the value of phi also by simply x is equal to r sine theta cos phi, right? So as we have calculated the value of r, we have calculated the value of theta, we know the value of x. So from this equation you can calculate the value of phi also. So this is the way of calculating the value of r, theta and phi if you are given x, y and z. So we should know both the ways of answering the question, how the examiner is asking you, right? I advise you to do a lot of practice of this type of questions which are given in your book. Usually the question is asked from here. Now I am going to the next question, the question number 3. The potential energy of the particle under the action of force U is equal to 2x power 4 plus 3x square. Find the force acting on the particle. So for U is given 2x power 4 2x power 4 plus 3x square. This is question number 3, right? Now you are asked to find out the value of a force, right? The potential energy is given you. Now for finding out the force, you must know the relation between the force and potential energy. F is equal to minus grad U, or sometime we write it as B. So it has the same meaning. If I write it in the derivative form, it becomes minus curly V upon curly X. If we are taking, not X, let me write it curly R. If we are talking about the three-dimensional case, what here we are given a one-dimensional x power 4 x square. So I can write it minus curly B upon curly X. Now in place of B, they are writing it as U. Same thing, potential energy. I can write it is minus curly U upon curly X. That will be the force, right? So you simply do the derivatives, minus curly upon curly X into 2x power 4, right? Plus 3x square. So you have to take the derivative. What you will get? 8x cube minus 6x. So this is the answer. Very simple question, but it is simple only when you know the relation between the force and potential energy. F is equal to minus grad B, right? Or minus grad U. This is the relation between the force and the corresponding potential energy, right? This was the third question. Now I am coming to the fourth question, right? What are inertial and non-inertial frame of reference, right? So question number 4. What are inertial and non-inertial frame of references? So if I talk about the inertial, inertial frames are those frames in which law of inertia holds good. Or we can say these frames are either at rest or they are moving with the uniform velocity, right? All these frames are known as inertial frames, right? Or inertial frame of reference. So what I said, either it is at rest or moving uniform velocity. Then that frame is known as a inertial frame or inertial frame of reference. For non-inertial, the frame is having some kind of acceleration, right? Either it is translational acceleration or it is a rotational acceleration. So when any kind of acceleration is there in the frame, then that frame is known as a non-inertial frame of reference, and in that frame the law of inertia does not hold good. Newton's law does not hold good, right? So the answer will be the frame that has some kind of acceleration, right? And the law of inertia not hold, right here, but it hold here in inertial frames, right? Once again I'm repeating, inertial frame is that frame which is either at rest or moving with the uniform velocity, and the law of inertia hold good in that frame. Newton's law of motion hold good in that frame, but non-inertial frame of reference, it is accelerated, whether it is translational, it is rotational, right? And law of inertia is not more valid in that frame, right? So this is question number 4. Now I am coming to question number 5. What are central forces? Give some characteristics of central forces. Question number 5. Is it question number 5 or question number 6? Yes, question number 5, right? It is question number 5, right? Here the question is, what is central force? Give some characteristics of a central force. Now first of all we have to define what is a central force. So central forces are those forces which act along the line joining the center of two bodies. Suppose we have these two bodies, so then the central force will be that force which will act along the line joining the center of these two bodies, right? I mean the force that act along this line. This force will be, if it is mass m1 and if it is mass m2, then if the force is acting along the line joining the center of these two bodies, then that force is known as a central force, right? What I said, the line of action is along the line that is connecting the center of two bodies, right? So as I told you that the central force is acting in this way, so we can write this force F is equal to force F magnitude dependent on R and a unit vector R. R is this uh, uh, vector from these two, between these two centers, right? So in this way you can see simply that the central force will act along the line joining the center of these two bodies, right? And its magnitude will only depend upon this distance between these two centers, right? And we can write it in this way. Now examiner is asking you about the characteristics of some characteristics of central force, right? So characteristics or properties we can say. So we know very well that what are the characteristics of the central force. Central force is always a conservative force, right? The first characteristics, conservative force. Conservative force means curl of that force will be equal to 0. This is the first property, right? The central force is a long range force, right? It is a long range force, right? In central force field, the total angular momentum L, total energy E is always conserved, right? Conserved. Total angular momentum L and total energy E. When the body is moving under the influence of central force field, then its motion is always in a plane, right? It is always moving in a plane, right? So these are some properties of central force. Now you can give examples. The gravitational force is the classical case of a central force, or electrostatic force, not electrodynamics. Remember, electrostatic force, right? This is also a central force, right? So these two forces are the examples of a central force. These are the property: conservative, long range energy, total energy and angular momentum conserved. Motion is always confined in a plane. So these are the properties of the or characteristics of the central force. Now I am coming to the last question. That is question number. Here it is written 7, but it is, I think, question number 6. Right? What was the aim of Michelson-Morley experiment? Right? Question number 6. What was the aim of Michelson-Morley experiment? So you know very well that Michelson-Morley experiment was performed in 1887, right? 1887 by Michelson and Morley to detect the relative motion of Earth with respect to ether, right? Hence, we can say that the aim of this experiment was to check the presence of or to detect the presence of ether medium, right? This was the aim, to check the presence of ether medium. Basically, what they were doing, they were measuring the relative velocity or speed of the Earth with respect to ether medium, right? They try to measure the relative motion of Earth through the ether, right? And they want to check whether this hypothetical ether medium exists or not. So this is the aim. You can write in one line also that this experiment was performed in 1887 by Michelson and Morley, and they want to detect the presence of ether medium in the universe. So this is the last question. I think one question is missing here. If I found that question from somewhere, then I will definitely take up in that next lecture. Because here we have only 6 questions. So they are writing here 7 into 2. Either it is a mistake in the question paper or one question is missing, right? So this is the answer to all the questions of first section, right? What do you mean by differential equation? Spherical polar coordinate in r theta phi to x y z, then potential energy problem, then inertial non-inertial frame of reference, central forces, and then aim of Michelson-Morley experiment, right? So I have answered all these questions. I suggest you to learn all the questions which are related to these questions, and I have explained you can go to the books, you can further go through them and enhance your knowledge, right? In the next lecture I will take section B, right? So thank you very much.